So in section 10.2, we talked about how to do simulation-based inference for two quantitative variables. And I showed you what the process would be. I didn't pull up the applet. I thought it would be easier to separately look at how to use the applet. And it comes, when you pull the applet up, it comes with foot length and height data. So we can see that foot length is positively correlated with height. And if we want to do the simulation, we need to click the Show Shuffle options, put in how many shuffles we would like to do, and select our statistic, which at this point is the correlation coefficient. So we can shuffle the Y values. Now over here, we can ask for the correlation coefficient to be computed. And we can select or enter that value to do our p-value calculation. All right, so again, the 0.711 correlation from our sample gets entered over here as count anything beyond, so on either side, that value. Okay. We can do the same simulation with the slope, and it will actually show us all the different slope lines. If we would like to see the slope here, we need to click Show Regression Line, and that'll tell us that the slope is 1.03. So if we enter that statistic over here, we get the exact same p-value result because we're using the same set of simulations. The slope is just a different statistic that summarizes those same simulations, and therefore our p-value should be the same. You'll notice that we can also do inference based on the t-statistic. We can do inference based on the intercept. We can do inference based on r squared. And don't worry about the f-statistic. We're not going to talk about that. All right. At some point, you may need to find the theory-based information for a regression. To get that from this applet, you click on the regression table, and you get a table here. It gives you the coefficient for the intercept, so that's what we've called A. It gives you the coefficient for the explanatory variable, in this case foot length, right? So that's what we've called B. And it gives you standard errors for those two values. It also gives you t-statistics. In general, when we're doing inference related to linear regression, we care about the explanatory variable. We don't generally care too much about the intercept. If the intercept is 0, that's actually fine. It doesn't matter that much. What matters in terms of what we care about is there's an association between the two variables, which is something that is going to come from the slope. All right, so you should know how to read this table. Conveniently, you also get a p-value that is theory-based from this t-statistic. So this is one of the easiest possible ways to get a theory-based p-value, which we generally haven't done before. You can also get it to give you a 95% confidence interval for the slope. This is a theory-based confidence interval. It will not match your 2SD confidence interval. And that's because we've simplified that confidence interval. The multiplier that you would get using normal theory-based inference is going to be something that isn't necessarily 2, which is why this will not match the confidence interval that you get. In general, when you are asked to get a confidence interval on an exam, I want the 2SD confidence interval and not the 95% confidence interval for the slope. All right. I think that is, for the most part, the set of features that you will need to do problems for this chapter. All right. So there's how to use your linear regression applet. Hopefully this has been useful.